Hey guys, another chapter 6 section 1 video here for you. Today we're working on how can I analyze an expression with exponent laws. So we're trying to build these things called exponent laws, which are basically shortcuts to how to handle the powers when we're simplifying. And today for our notes we're going to make a pretty detailed chart. We're going to talk about an expression and we're going to talk about the exponent laws, and I'm going to build this into kind of a T-chart. So make a big T-chart in your notes that says expression and exponent law. And we're going to get into the details of that. Now, you'll need a lot of space because we're going to go through each of these with an example. So let's start with the first one. Here's our expression. X to the third times x to the fourth. X to the third times x to the fourth. So this is a multiply problem. We're timesing the x's together. And one of the things we know is if we expand it out, x to the third is x, x to the fourth is 4 of them. So how many x's do we really have? We have 7. So our answer is x to the 7th. Now we want to look for our generalization. What is the rule? What is the law, the exponent law that's going on here? We'll look at the powers, 3 and 4. Now, I know it's a multiply problem, but what's going on with the actual powers? The powers are being added. 3 plus 4 is 7, the answer that we got. So on the exponent law side, I'm going to write x to the 3 plus 4 equals x to the 7th power. There's our rule. The rule is, let's make it generic, x to the a power times x to the b power is x to the a plus b. Meaning a and b can be any numbers, any power. It could be x squared and x to the 10th, x to the 30th and x to the 50th. Whatever the powers are, when you're multiplying, you add those powers together. So I'm going to write over here, add the powers. That is our exponent law. All right, let's look at another example. I'm going to draw a line under this. Here's our next expression. Fraction, x to the 5th over x squared. Well, if we were to expand x to the 5th out, this is obviously a divide problem because of the fraction. We would have x times x times x times x 5 times. And we'd on the bottom have x squared, xx. Now the power of 1s would go, and what are we left with? How many x's? 3. X to the 3rd power is our solution, our simplified answer. But what's the rule? What's the law that's going on here with this divide problem? Well, look at the powers, 5 and 2. What do we do to get x to the 3rd power? 5 take away 2. It's subtraction. So if it's subtraction, then over here on the law side, I'm going to write x to the 5th power over x squared is equal to x to the 5 minus 2, which is x to the 3rd power. That's our law. So with division problems, with fractions, we actually subtract the powers. That's our shortcut. All right, I'm going to draw a line under this. Oh, wait, let's put the generic version of this. X to the a over x to the b would be x to the a minus b. You could do this with any powers. So a and b are just numbers. Like it could be x to the 10th and x to the 4th, x to the 25th and x to the 13th. Whatever numbers a and b are, the rule is subtract them. That's our generic rule. Now I'm drawing a line under there, and I'm going to show you another expression. So I'm going to move this table up. The next one looks like this, a parenthesis problem. X squared in a parenthesis to the 3rd power. I'm going to write parentheses. So with parentheses, we still can expand and break this out. If it's to the 3rd power, it means there's 3 of them. X squared, x squared, x squared. And breaking that down even more means it's x times x, x times x, and x times x. So really, how many x's do we have? Yeah, there's 2, 4, 6. X to the 6th power is our simplified answer. But we're looking for a law. We're looking for some sort of rule that we can come up with. Well, what happens with these powers? 2 and 3. Well, the answer is 6, so what did we do with the powers? We multiplied them. 2 times 3 is 6. So our rule over here on the law side is we take x to the squared to the 3rd and we multiply it. X to the 2 times 3, which is x to the 6th power. That's our rule. Multiply the powers when you have parentheses. So generically, we could say we have x to the a power to the b power. The rule is x to the a times b. Whatever a and b are, you multiply them. All right, let's back up and look at this information a little bit like zoomed out now. Here's our table. We've got 3 different exponent laws. The first one is when you're multiplying, you add the powers. Second one is when you have a division problem, you subtract the powers. And the last one is when you have parentheses, you multiply the powers. What do you think the common mistake everybody makes after they forget some of these rules? Like, a lot of people learn them for a day and they really get it down, but then like a week later they kind of forget them. Well, the common mistake is on a multiply problem, they'll multiply the powers. They'll forget to add. Or on a divide problem, they'll divide the powers instead of subtract. So you got to remember that there's some kind of weirdness to these rules. All right, I'm going to put a little thought cloud to the side of this table, and I'm going to write the laws are shortcuts, but expanding will always work. These exponent laws are really nice little shortcuts, but if you're going to get them all mixed up in your head, or 3 weeks from now you're going to forget them, what you need to really remember is you can always expand, and it will always work. Break out into small parts, put it back together. Expanding always works. So now there are some weird cases that I'm going to introduce you to today. 2 weird cases. Here's case number 1. X to the 5th over x to the 5th. That's a weird case. Why is it a weird case? Well, what's the exponent law for dividing fractions? What do we do with the powers? Do you remember? We subtract them. It'd be x to the 5 minus 5, which is 0, x to the 0. And people get very confused by x to the 0 power. Everyone's like, is it 0? Is it nothing? What is it? But let's think about breaking this out with expansion. X to the 5th would be x over x. 5 times on top and bottom. Power of 1s are going to start crossing out here. And when we're done expanding and simplifying, what are we left with? Well, we're left with one big power of 1. That's all that we're left with. So what is x to the 0 power? It's 1, which is really weird. Most people are like, how is that possible? But if you show the expansion, oh, it makes sense. Anything to the 0 power is equal to 1. 0 powers equal 1, which is actually pretty helpful. Let me show you an example of some 0 powers. I'm going to show you 3 of them, ABC. So make some space in your notes for ABC. So like, here's an example, 7 to the 0 power. Most people think it's 0, but it's not, it's 1. Anything to the 0 power is 1. How about 1/2 in a parenthesis to the 0 power? Well, it's to the 0 power, so it's got to equal 1. Or like this thing, 4x squared in a parenthesis to the 0 power. No matter what it is, if it's to the 0 power, it's equal to 1. That is a rule that we just kind of start to memorize. All right, what's another weird case? Well, here's weird case number 2. Weird case number 2 would be a problem like this. 2x to the 3rd over x to the 5th power. Why is this a weird case? Well, what's the rule when you're dividing fractions with the powers? The rule is subtract. So it'd be 2x to the 3 minus 5. But what's 3 minus 5? That's a negative number, 2x to the negative 2 power. And most people do not know what to do with negative powers. We don't like negative powers. They're not very helpful to us. So what does this actually mean? We'll look at it through expansion again. 2x to the 3rd would be 2x times x times x. And on bottom you'd have x to the 5th, so x. Get rid of your powers of 1, and you're left with a 2 on top and x times x on bottom. Where are the x's? They're on the bottom of the fraction. So it's 2 over x squared. So what do you think that negative power means? That negative power means it's supposed to be in the bottom of the fraction, that it's in the wrong location. 2 over x squared is really what it's equal to. So negative powers tell you the term is located in a different place on the fraction. It's an indicator. If you have x to the negative 2, you're like, oh, it's supposed to be on the bottom of the fraction, x squared. That's what it actually means. Now let me show you an example of how these work. We'll do 2 of them, A and a B. So here's an example of a negative power problem. 2x to the negative 4th power. What does that really mean? It really means 2 over x to the 4th power. And when you fix it and you move it to the bottom of the fraction, then you don't need the negative power anymore. It's just x to the 4th. And that's what we want to do. We want to get rid of the negative power and make it go away. How about this one? 3 over x to the negative 5th power. What do you think about this one? It's already in the bottom of the fraction. Well, if it's a negative power, then it's telling you it's in the wrong location. I guess it was actually supposed to be on top. 3x to the 5th power. Now we fixed it. It's on top of the fraction. All right, let's try another problem, example 3. Let's simplify this thing. X to the third y squared over x to the 6 y to the 4th. Now, mathematically, we could just break it out, but we're going to use our exponent laws and subtract our powers. We're going to have x to the 3 minus 6 and y to the 2 minus 4. That's x to the negative 3 and y to the negative 2. And what do negative powers tell us? They're in the wrong spot in the fraction. They should be on the bottom. X to the third, y to the second. But what's on top? There's nothing left over. Well, power of 1. Power of 1 is left on top. 1 over x to the third y squared is our solution. All right, let's try another one. Example 4. This time we're going to do this problem. X to the negative 5th times x squared. Times x squared. What do we do when we multiply? Look back at your exponent laws. What's the rule for multiplication? What do we do with the powers? We add them. So this is an addition problem. We're going to do x to the negative 5 plus 2. And negative 5 plus 2 is negative 3. So we're almost done. We kind of have our answer, except we have a negative power and we don't like negative powers. So move it to the bottom of the fraction and put the power of 1 on top. 1 over x to the third is our solution. Okay, let's try another one. Example 5. The more I show you of these, the more comfortable you'll get. So here's our problem. A to the negative 3 times b to the 4th. Multiplication problem. And what do we do when we're multiplying? We add the powers, but this is an a and a b. So different variables. Can we add negative 3 plus 4 if they're different variables? No, we cannot. So do not fall for the trap. Don't start adding powers because one's an a and one's a b. So instead, we're just going to fix that negative power and put it on bottom and make it, let's see, I'm going to kind of put it together. Make it b to the 4th over a to the 3rd. And that's it. There's nothing else you can do. It is simplified. Different variables, you can't do anything else. All right, let's try another one. Example 6. Here's a parenthesis problem. A to the 3rd b squared to the negative 2 power. This is actually kind of a hard one. What's the rule with parentheses if you look back at your chart in your notes? What do we do with parentheses and powers? Yeah, we multiply them. So that a to the 3rd, we're going to times it by negative 2. And that b squared, we're going to times it by the negative 2. We're going to multiply those powers. Now that's a to the negative 6 and b to the negative 4. And since they're negatives, what do? We put them on the bottom of the fraction. A to the 6, b to the 4th with a power of 1 on top. That's our simplified solution. So with parentheses, we multiply the powers, but if they're negatives, we got to move them in the fraction. All right, example 7. Another parenthesis problem. 3xy squared squared. Well, what do we say we do with parentheses? We said we multiply the powers. Now for this one, it's a little tricky because we have a 3x on the inside. That's like 3 to the 1st power and x to the 1st power. We just don't write first powers. That'd be kind of strange. But it's going to be helpful for when I multiply my powers. That's going to be important. So I'm going to have 3 to the 1st times 2, x to the 1st times 2, and the y squared times 2. Now that'd be 3 squared, x squared, and y to the 4th. Now what is 3 squared? 3 times 3 is 9. So the answer is 9x squared y to the 4th. That's my simplified solution. All right, your turn. You're going to try a problem. So here is your you try problem. 4x squared y to the 0 times 2xy. Right now, hit the pause button on your device and try to simplify this problem. Good luck. Okay, you ready to check your answer? Let's see how you did. So first off, I'm noticing a 0 power. And what is anything to the 0 power? 1. So if that's a 1, that's going to make this problem a little easier. That means I have 4 times 1 times 2, because there's a 4 and a 2. Put the numbers together. X squared plus the other x would be x to the 2 plus 1. And then there's just a y. There's nothing to put the y with. So 4 times 1 times 2, that's 8. And then we have x to the 3rd and a y. And our answer is 8x to the 3rd y. How'd you do? Did you get the same thing as me? You might have done this a different way than me and still got the same answer, and that's okay too. There's not one right way of doing these problems. There's usually a couple different ways you can do these problems. But as long as you're showing your work and we're getting down to the same simplified solution at the end, then we should be okay. Alright guys, so that wraps up this video. We basically just have to remember that we have 3 exponent laws. When you're multiplying, you want to add the powers. When you're dividing, you want to subtract the powers. And when you have parentheses, you want to multiply the powers. Thanks for watching guys. I'll see you in the next video.